Hi everybody, welcome to, I think it's week 6 or 7. We're looking at graphs, the midpoint of a line, and the rise over run. So I want to take a second and think, what is a graph and what do we use it to represent? And what are the different types? We have 30 seconds to have a think. What are the types of graphs? And what information may we use? So I'm going to give some examples here of some information we might want to use to portray on a graph. So do tomatoes grow faster under fluorescent incandescent or UV light? Think about how we want to represent this data. What kind of graph would we use? What do we need to use? Are we going to use a line graph, a bar graph, a pie chart, scatter plot? So we've got more than So we're not really worried about ordering them. We're not really worried about this question. But how would you represent that data in a graph? So because there's more than 2 variables, so fluorescent, incandescent, and UV light, you wouldn't use a scatter plot. You wouldn't use a pie chart. You would use a bar because you could represent 3 different variables like this. And you would get a clear visual representation of which of these variables cause the plants to grow better. So you wouldn't use a pie chart because you're not looking at the distribution of something. So we need to be able to clearly see a difference between more than 2 variables. We use bar graph. So we could ask, how does phone use affect sleep? Would we use a scatter plot? Would we use a bar graph? Would we use a pie chart here? What are we thinking? So here I have 2 variables with a clear cause and effect, or independent dependent variable. So clear independent and dependent variable. So easy way to think of these two things is the independent variable is the cause. And this is the effect. So I want you to take a minute and try it. So these two variables, which one is the cause and which one is the effect? Okay, so the cause in this case is the amount of time we're actually going to practice building these graphs spent on the phone, because we are looking at is the amount of time we spend on the phone before bed, does that affect our sleep? The effect is the sleep. So let's put this into a bar graph, and I'll show you why you wouldn't use a bar graph. So when we're building a graph of any kind, we have two axes, and this is going to highlight my lack of drawings. Which variable goes where? So I would put the number of hours on the phone or the independent variable. On this side, I will put the hours of sleep. Now, a bar graph is great for displaying information. But as you get into grade 8, 9, and 10, up in that range, you will find that you also need to analyze the data. So displaying, analyzing a scatter plot. Listen. So if I wanted to say, okay, 0, 1, up to 5 hours before bed, here hours of sleep. Wish I got 7 hours of sleep a night. So let's say if you spend 1 hour a day, you get 7 hours sleep. 2 hours, three. So for every, so what does that tell us? Oh, sorry. So what does that tell us? I mean, it looks pretty on the graph. But we can't analyze the data. We can say, actually, it looks like the more hours you spend on your phone, the less sleep you get, right? It's a pretty safe bet here. When we start looking at scatter plots, and the whole reason you learn algebra so now let's do a scatter plot. So this tells us that there is a trend here. So this is telling us that as you increase phone use, sleep goes down, right? And this is what we call a correlation. If the line is sloping this way, down from top to bottom, it's a negative correlation. If it's going this way, it's a positive correlation. So a negative correlation says that when you increase this variable, this one goes down. Why did I sneeze so much? So negative going that way, positive going that way. So it's what we call a correlation. So positive meaning for every increase down here, you would get an increase on this axis. A negative says that as you increase this variable goes down. Now, why is that important? So we need to know the slope. So we need to know the slope and the midpoint of this line. We need to know the slope and midpoint. Now I'm going to get rid of this and I'm going to make it a bit neater and easier to use. So we use this kind of stuff to analyze data. So the classic correlation is autism diagnosis and the number of vaccines given to kids. It matches almost perfectly. But so does organic food sales and autism. So you have to be careful with this correlation. It doesn't mean much. So we're going to first calculate the midpoint of a line. So that is the point, is exactly halfway to the line. When you get halfway down the line, right in the middle, I guess is another way to say that, probably a better way to say that. When you get to grade 10, you start looking at the graphs in real detail. You start using y equals mx plus b, and you can plot unknown points on here. But we're just going to learn these basic steps. When you get to grade 10, it's easy. Okay, so we have a line on our graph, x-axis down here, and y-axis going down. So we have a line here. So at this end, its point on the x-axis is 1. Point on the x-axis is 1, so we write 1, comma, and the point on the y-axis is 2. So we go up here, go up to 7. 10, that's in line with 4. So x-axis, 4 and 7. So I want to know the exact midpoint here. I mean, you could eyeball it and say, well, it's between 2 and 7. So what's halfway between there? But that doesn't work when you get into grade 10. So it's quite a simple way to do it. You add the two x values, 4 and 1. 1 plus 4 divided by 2. Then we have 7 plus 2 divided by 2. So that gives us 5 divided by 2 and 9 divided by 2. Or 2.5 and 4.5. Okay, so 2.5, if we look here, is here. And that is exactly halfway, if you look at the line here. So that's our midpoint. So if you want to take that down, I'll give 30 seconds to write that down. So we're going to practice 4 or 5 of these until we get it mad. So if we look at numbers of so using that same method of adding them together and dividing by 2, tell me the midpoint of this line. So 1 minute, do a few of these. Then we will do rise over run. I think I will use the internet. So Izzy says 3.5 and 6.5. 4 plus 3 divided by 2. Perfect. So I'm going to make it significantly more difficult in a second. So if you get this one, you'll be fine. So same thing, 11. What was, why don't I keep going page? And 17 plus 4. Just when you thought, hey, so 7. I'm going to throw a curveball. So throw a curveball in. And you want to know what to do here? So 3 plus 4. So Izzy said 3.5 and 5.5. So 14 plus minus 3. And we know that if it's a plus and a minus, it becomes 14 minus 3. 5.5. All right. Well done, Izzy. I'm going to do one more and I'm going to throw you off completely. 1 minute. So what's -3 plus -10? -13. So we divide that by 2. In division, if there's a minus and a plus, or a positive and a negative number, the answer is negative. So -6.5. And then Izzy is right. 28 divided by 2 is 40. Okay, cool. I think you guys, that's a simple enough explanation of that. I'm going to bring something up on the computer because I'm not going to try and draw it. Now we're going to look at angle or the slope of the line. Let's see what I will be. I need to remember to pin myself. Okay. Where is line? Okay. So now we're going to look at the slope. And this tells us the line. Wow, that was good English. Tells us the slope of the line. How close to vertical is it? Is it almost flat? Is it perfectly correlated? And it's quite simple. It is rise, as in rise over run. Or the beginning X number divided by the final X, Y number. So this line goes up 3 squares and goes across 3 squares. So the slope of the line is 1. The steeper the line, the bigger the slope. So this goes up, which is the rise, and 2 across, which is the run, 4 divided by 2. So this one, the rise, it goes up by 3 squares and across by 5 squares. So if it's going down, it's negative. If it's perfectly flat, it's 0. Going upwards, it's positive. So if it's sloping down, it's a negative number. If it's going across, there's no rise. It's 0, so you will get a 0 number. So if it's straight up and down, then it's undefined. So we're going to do some questions. Finish off here. You're going to have 1 minute to finish all this. So remember our rise divided by run. What is the gradient or the slope of this line? 1 minute. Can't open the chat for some reason. So 1/2, 1 out of 2. So if the rise is 2 divided by the run, Izzy says 1/2. We're going to go with Izzy's answer. Perfect. So 2 divided by 4. All right, Izzy, you're up again because you're the only one here today. So, Izzy, what do we got? Rise is 5. Divided by 3 should give us 1.66 or 1 2/3. We know it's positive because it's going up. So 1 2/3. 5 divided by 3. So 1 minute on this one. So what have we got? Rise is 1 2 3 4 5 divided by 3. So by my maths, it should be negative 1 2/3. Hopefully I'm right. Otherwise I look very silly. So minus 5, because even though it's the rise, it's going down. So this one here. Okay. So here, we know it's a minus number because it's going down. The rise is 2 divided by 6. sorry, minus 2. So that should give us minus 1/3. So minus 2 divided by 6 gives us minus 1/3. So again, 30 seconds to do this one. So we remember that if it's going straight and there's no rise, it's 0. So there is no gradient, it's perfectly flat. This question should get a few of you tricked. I don't believe it. I give everyone 1 minute to figure it out. Okay, if you're confused, that's okay. All we're worried about is this portion of the graph here. You'll get to do quadrants and all that fun stuff in grade 10, 11. For now, we're just worried about this. So only this little quadrant here. So the rise is 1, 2, 3, and the run is 1. So 3 divided by 1 should be 3. Perfect. All right, that should give you a really good introduction to the graphs, and especially if you're going into grade 10 now. You'll be doing a lot of that. I will see you guys next week. Have a fantastic week, and I'll see you next week.